In this video, we'll continue discussing higher-order functions by looking at FlatMap. We'll see FlatMap in context by experimenting in a playground. Finally, we'll implement FlatMap in game of life. FlatMap is useful while working with both single and multidimensional arrays, or arrays with optionals or nil values in them. Looking at the definition in Swift, we see that FlatMap takes any type that conforms to sequence type. Just as with map, the transform closure gets an element from a collection and runs the closure on each item in the array. FlatMap then returns a type conforming to sequence type. As usual, I'll have some additional notes on FlatMap on this video's resource page. Let's look at a playground to see FlatMap in action. Here, we are defining a constant that consists of an array of arrays, also known as a multidimensional array. If we run FlatMap on our animals array, it will return a new flattened single-dimensional array. The FlatMap function also checks whether an optional value is non-nil. If it is, the value is passed on to the argument function. If the optional argument is nil, the value is excluded from the output array. Here we have an array of optional int values. Notice that we have multiple nil values in our numbers array, and our output array is not only flattened, but contains only non-nil values. If we perform the same operation with map, our function returns optionally wrapped integers along with the nils we passed in. FlatMap becomes really interesting when we use it in combination with other higher-order functions. Here, we have defined an array of dictionaries that contain people objects. We're utilizing FlatMap to look at the flattened dictionaries and map to increment each value by 1. We'll look at more complex chaining in our next and final video on higher-order functions. But now that we have a handle on FlatMap, let's use it in our game. In order to use FlatMap, we'll need some values to iterate over. We can change our grid size variable from an int to a range of int. I'll also shorten the name to grid. We'll comment out our for loop code for clarity. Next, we'll remove the value from our cells variable and reference our new range, followed by FlatMap. Then, in our closure, we'll add xin to define our closure's instance variable. Then, we'll repeat the same logic for our second loop, this time with map. In our map closure, we'll use yin for the instance variable. Finally, we'll create our instance of cell and then return our cell's variable. So far, this isn't any shorter, but we can work on that. I'll start by removing the yin and using an implicit variable. Then we can put map on a single line. This is much better. Actually, we can reduce this entire statement down to a single line by just returning our closures. If we're really going for shorthand, we can remove the self.grids and replace them with ranges like this. No more need for the weak self-in expression either. This is an excellent example of how much code you can reduce by utilizing higher-order functions in Swift. In this video, we looked at how FlatMap is defined and how it works. In the next video, we'll conclude our discussion on higher-order functions by discussing reduce.